The second method, the charging by induction. Induction means inducing something from a distance without touching. There is another term, conduction, means we can also create charges using the method of conduction. Suppose we have a body which is already charged, maybe by the basic method of friction, and there is another body which is not charged. And if we bring these two objects in contact, then charge will be transferred from one to the another in such a way that some kind of equilibrium will exist, and that particular amount of charge carried by the first object will be shared between these two objects. So that is the method of conduction. So in method of conduction, you will have to touch the objects physically, means the two objects must come in physical contact. But here I am talking about the induction. Induction means action from a distance. Without touching the object, we are trying to induce the charge in neutral conducting objects. Hold on, that I am talking about the conducting objects. Conducting means the objects, the metals in which there are plenty free electrons roaming around inside the metal boundary. Actually, what happens when we bring one already charged object near to some uncharged metal object, the presence of the charged body near the neutral conductor will force the electrons within the conductor to move because of this force of attraction. Suppose this positively charged body is brought near to uncharged object, then what happens? Electrons are attracted towards this object. And so this way, on the other end, we'll get positive charge, and on this end we'll get negative charge, because we have brought a positively charged body near to an uncharged body. So in this process of induction, you can see that we haven't created any net charge because this object is still neutral. It's only that at this end of this object there is a majority of electrons. So here it appears as the negative charge, and here the majority of the positive charge. So it appears as positive charge on the other surface. But overall the object is neutral after the induction also. So at this moment, if we remove this object from here, then what will happen? The process will be reversed and it again gets neutral. So if we remove the object, then the whole process of induction is nullified and the object again becomes neutral as it was before. Actually, after the induction it was neutral, but there is an imbalance of charge on the two sides of the body. But there is a trick using which you can somehow hold the charge in this object after even removing the object which is used for inducing the charge. Suppose we do the induction again and bring that object near to it so that it is charged by induction and its opposite nature of charges appear. And now here, hold on, this is one object which is connected to Earth. We must know that Earth is a very, very huge reservoir of charge. That means if we extract many electrons from the Earth, then it's not going to make any difference to it. And even if we want, we can dump the electrons into the Earth, and even that, it is not going to make any change in its situation. So Earth is used as a huge reservoir of charge where we can dump the charge or we can extract the charge as per our purpose using certain tricks. So in this case, when this object which is connected to the Earth is brought in contact with this object, then what happens? As you can see here, that because of the presence of this positively charged body, there is a tendency of the electrons to move this way, in this direction. Suppose in this layer some electrons are moved here, then here it becomes positive. Then the other layer loses the electron and the electron reaches here, and this portion becomes neutralized and positive charge appears at this end. And this way, slowly, this positive charge keeps moving as away as from this negative end as possible. And here you can see that these electrons are attracted by this particular object because these two are oppositely charged objects. That is why we say that this particular charge is known as the bound charge because it's bounded in the presence of this. And the charge on this end is known as the free charge because as you saw in the animation that as we bring this object near to it, then electrons started transferring from this location to this, then this location to this, from this, and in this way that this positive charge will move as far as the way possible. So because of this positive charge, when this object is brought into contact and this object is connected to the earth, this is earthed object. Remember that it is earthed object which is to put in its contact. Then what will happen? Because of this positive charge will attract electrons from the earthed object, and electrons will flow from the earthed object and will neutralize this charge appearing on this surface. So here you can see that how these electrons will start flowing from the earth to neutralize this. And now the situation is something like this, that the free charge has vanished and only the bounded charge is there. This charge cannot move because this particular object is applying electrostatic force of attraction on this charge. That is why it is there. So from earthed object, electrons are flown to this body and this positive charge which was appearing on this side has disappeared because of the neutralization process by those electrons, because it was positive. So electrons carry negative charge and these two combine together to get neutralized. When this object remains connected to this, then what will happen? Suppose you forget that you are not going to move this object and just remove this object from here, then what will happen? These electrons will flow to the earth and again it will get neutralized, because at present effectively these electrons are those electrons which are transferred from the earth in indirect way, because the electrons from here has gone to this location and further electrons are moved from the earthed object here to neutralize that. So in a nutshell we can say that these are those electrons which are actually moved from the earthed object, and these electrons are there just because this object is present, because this object is holding on these electrons and making them bounded. So if you remove this object while this object is connected to this, then it's not going to help because these electrons are quickly going to flow inside the earth and your efforts will go waste. So what will you do? We'll do that first remove this earthed object in its presence so that this object may not allow these electrons to flow back to the earth. And when this object is disconnected, after that you remove this object from here and now these electrons will distribute inside this metal uniformly and we will get a negatively charged object like this. So first remove this and then remove this charged body so that these extra electrons remain there only. And when we remove this object, then since there is no boundation on these electrons, so these electrons will be redistributed uniformly all over the metal object. And this way we have got one negatively charged body. So have you liked this trick, the method of induction, that we have not wasted our charge, that we created some charge using the method of friction, and then just by inducing and using a certain trick, a kind of intelligence trick, and we have created another body, negatively charged body. I can give you one more example for this. Suppose we have one spherical object here and we bring another charged body, say it is positively charged, in its presence. What will happen? Electrons in this sphere will be drifted towards this positively charged body, and because of that here the net positive charge will be shown, because the deficiency of the electrons, because electrons are moved from this location to that location, same as that we have seen here. And now suppose we have another sphere kept nearby. then because of this positive charge is going to attract electrons of this object. So at this end electrons will get accumulated, and over this end the same amount of positive charge will be created. So this is the scene. And in the second step, suppose in its presence we bring these two objects in contact, then what will be the situation? Can you guess that? This object is there in its presence, we have brought these two in contact, then what will happen? It was negative charge here and positive charge here, negative charge here and positive charge here. So from this area the excess electrons will be moved to neutralize these positive charges. So the end result will be this. Here it is positive, here it is negative charge. So after touching these two objects, if we now remove this object from here, then what will happen? These two bodies will again get neutralized. So what will we do? We'll use the same trick, that just remove this contact in presence of this object, that let this object be there only and separate these two spheres. Then what will happen? Here negative charge is bounded, and now separate the other sphere to some other location so that its positive charge is equally distributed inside the sphere. And now you can remove this object to anywhere. And after this, what will happen? The total negative charge will be uniformly distributed within this sphere. So that is how we will get two charged bodies but having equal and charge of opposite nature. Here, since we have used the earthed object, so that particular charge has gone. But in this case, we are using another object in place of earthing. So this way, what we have done, that in its presence, we are touching two spheres against each other so that electrons are transferred from one sphere into another. Since we know that this particular charge is bound charge, so in its presence this particular charge is not going to anywhere, and so in its presence you just remove this sphere so that the positive charge of this sphere is uniformly distributed over its entire volume, and after that you remove this object to infinity or anywhere else, so that in this sphere this particular negative, which was bounded charge, gets uniformly distributed throughout the volume. So this way we'll get two bodies of equal and opposite charge. So what do you think? The trick is good or not? Of course it is a very good trick to generate the charges by the method of induction. Otherwise, induction doesn't have capability to produce net charge. Because of the induction, there is only redistribution of electrons within the object, so that at one side there is negative charge and on other side there is equal positive charge. But as soon as you remove that charged body, that object is going to be overall neutral again. So induction in itself cannot create net charge, but if you use your intelligence in such a way, using some earthed object or some other object in place of that, then you can create charged bodies in this fashion. So it is in fact a very intelligent method to create the charges. So now just revise the video which I have shown to you. Initially it was a metal object. So everywhere electrons and the positive ions are there. So there is no net charge everywhere inside this. But we know that there are plenty free electrons which are roaming around inside the metal everywhere. But the overall distribution is such that there is no net charge. But when we bring another charged body near to it, then what happens? Suppose this is positively charged body, then it will attract electron towards it, and so on the other hand the same amount of charge will be created. And now in the presence of this body which is inducing the charge, we'll connect the metal object to earth, and because of that electrons will flow to this object to neutralize this charge, and this way we are here, and in presence of this object just remove the contact with the earth. This symbol is used for earthing. So in its presence, if you remove the earthed contact, then this object, by applying electrostatic force of attraction on these electrons, won't allow these electrons to go back to the earth. And after disconnecting from the earth, if you remove this object to any place, then the whole negative charge is going to get redistributed inside this material object, and thus we are going to get a uniformly charged negative body. On the other hand, if we bring a negative charge, then what will happen? Suppose this is a metal object and we bring another negatively charged body, then it will repel the electrons, it will go to that end, and so positive charge will be created at this end. And now in its presence, if we connect this object to the earth, then since these electrons are trying to move as away as possible, because this is free charge and here it is bounded charge, so these electrons will flow to earth opposite to that. Here electrons were flowing from earth to this object to neutralize this positive charge. Here the electrons are moving from this metal object to the earth, and this way this whole negative charge here disappears. So we get this object as the positive charge is here in the presence of this negatively charged body, and we have disconnected it with the earth. So now you can remove this body to any other place, and that is how we'll get a uniformly charged, positively charged object. Here I have used positively charged body to induce the charge, and now here I have explained the same way how to bring the negative charged body and how to do the things. The only difference is that in this case electrons are moved from earth to the object, but here electrons are moved from object to the earth. That is the only difference. So hope you have now understood the whole process of charging. The basic method of charging is friction, and using frictional electricity we can create charges, and after that using the method of induction, and the common sense is the conduction process. If you touch two objects, one of which was already charged and the other was neutral, then obviously there is going to be redistribution of charge between those two objects. So there is nothing very intelligent in this conduction process, but the whole intelligence is here, induction process. In case of induction, we don't touch the charged object to other body which was neutral. We just induce the charge and use an intelligent trick so that that object retains the charge after even removal of the inducing object. So that is how it's all about the charging process. In the next video, we'll learn about the force acting between two charges. That means we will introduce you with the Coulomb's law, which is about the force acting between two charged particles, and we'll do some calculation based numerical examples for this. So just watch the next part of this session to learn about the force acting between two charges, or in other words, just learn what the Coulomb's law is.